Hi, let us see what is stack data structure and how we can use stack data structure. Stack data structure stores, removes uh, elements in a particular fashion called last in, first out fashion. Let's see some examples. When we create a stack, we need to declare the data type of a stack, just like arrays. Let's say if you create a stack of type integer, then we can only store integer values inside that stack. Similarly, if we create a stack of type string or any other type, we can only store that particular type of elements inside a stack. Okay, this stack has some operations. Let's see what are this. First is push operation. The push operation is used to store or add elements inside the stack. Let's say we create one integer stack, and let's say first we add a value called 10. So if we do push of 10, we can insert 10 inside the stack. So let's say we add one more element called 20 and another element called 30. So if you do push of 10, push of 20, push of 30, we can insert these elements inside the stack. The second element is pop. Second operation is pop. Pop is nothing but to remove elements from the stack. When we do pop, it will only remove the topmost element inside the stack. So if you see this last in first out, so whichever is added at last is removed first. So this is how stack works. Let's say if you want to delete 10, we cannot just go to this 10 directly and delete this. We first need to delete 30 and then delete 20, and only then we can delete 10. So these are the two major operations inside a stack, push and pop. So when we add elements, it will be stored like a pile of elements like this. When we do pop, we will remove the topmost element inside a stack. Few more operations in stack are empty. This will tell us if the stack is empty or not. And then there is an operation called clear. Clear will delete all the elements in the stack. And then there is an operation called peek. This will tell us which is the topmost element inside the stack. So these are the operations we can do inside a stack. Let us practically declare one stack and try all these operations. Yeah, so stack comes under collections framework. So if you want to use stack, we have to import this Java and util collection framework. So this is how we declare a stack. So stack, and then the type of stack we want to create, and then the new stacks to create a stack, and this is the variable name we assign for a stack. So this is an example of creating an integer stack. This is an example of creating a string stack. Let's try creating one stack and do this push pop and other operations. So I've just created one online compiler, and we have imported the Java util collection. Here we have created one integer stack. So what it will do is it will create one stack like this and keep it empty. Now let's say we add one element, stack dot push of 10. Now what will happen is in this stack one element will be added called 10. Next, if you do push of 20, uh, now another element called 20 will be added inside the stack. Now let's say if you print the stack, sorry, already so let's say if you print the stack, it will print 10 and 20. Yeah, 10 and 20. Okay. Now, if we do stacks of peak, this will check the topmost element inside a stack. So we are added 10 and 20. Now 20 is the topmost element. So okay, I think it is only printing this. Okay, maybe if I do it here. If we do stacks.peak, then it is going to print 20, which is the topmost element here. Okay, now if we do stacks of pop, now what happens is we have 10 and 20 in the stack, and 20 is the topmost element inside the stack. So when we do stacks.pop, when we remove the topmost element in the pop, 20 will be removed from the stack and only 10 will be there. And then when we do stacks of peak, 10 will be printed. Yeah. If we just do stacks as well, only 10 will be there in the stack. Okay. Let's say if we do stacks.pop again. So now what happens is we are first adding 10 and then we add 20. Now when we do first time stacks.pop, 20 will be removed. When we do second time stacks.pop, 10 will be removed. And when we print stack, there is nothing to print, an empty stack will be printed. Sorry, semicolon. Okay. Yeah, one empty stack is printed. Now let's say if we do stacks.pop again, there is nothing to remove. For example, we add two elements and some error. Yeah, it says there is nothing to remove in an empty stack, so that's the error we get. And there is other operation called empty. Like if we print stacks dot okay, this will say if the stack is empty or not. First we add two elements and then we are removing those two elements. Now if we check if stack is empty, this should print true. Let's see. Yeah, true. In case if stack is not empty, it will return false. Let's say I am again adding a new element after removing them. Now this stacks of empty will say false because the stack is not empty now. Yeah, so what happened is we created one integer stack. We first added 10 and then we added 20 and then we first removed 20 and then removed 10. Again we added a new element called 30. So when we check if stack is empty or not, we have one element and stack is not empty, so that's why we are returning false. So this is how we create a stack. This is how we add elements and remove elements inside a stack. We use stacks.empty to check if stack is empty. We use stacks.peak to check the topmost element of a stack, etc. Now if we see where we can use this stack, we can use the stack data structure in some situations like evaluating order of elements or expressions. In such situations we can use stack. In upcoming videos we can see some problems where stack can be used and solve the problem using stack. Thank you. Hi, let's see lead code question. This is a very famous question. As you can see, this question has been asked in a lot of companies, uh, and this is also a best question where stack data structure has to be used. So let's see this question. So in this question they are saying that they will give one string, and the string will contain only these 6 characters or these 6 brackets, and we need to check if the string has valid parenthesis or not. uh, they have set of rules to define if it is a valid parenthesis or not. Let's see the rules. First rule what they are saying is open brackets must be closed by same type of brackets. So we have 3 type of brackets here. One is this bracket, one is square bracket, and one is curly bracket. So what they're saying is open brackets must be closed by same type of bracket. So if we have this bracket, then this is the corresponding closing bracket. For square bracket, this is the corresponding square bracket, and for this is the corresponding square bracket. So when we have these kind of opening brackets, the corresponding close bracket should be there. And the next rule what they are saying is open brackets must be closed in correct order. So let's say if we have a string like this, and we have two open brackets, one is this bracket, then another one is square bracket. So when we have these two brackets, the closing bracket order should be like this only. In case if it is changed like this, then it is invalid. This is valid. Yeah. And the third rule what they are saying is every close bracket has a corresponding opening bracket of same type. Again, this is similar to the first rule. So every open bracket should have the corresponding closing bracket. In case if we have a string like this, then this is invalid. Opening brackets must always come front before the closing bracket. Let's quickly check the test cases they have given. So in the first test case, the opening and closing brackets are of correct order, so it is valid. In second test case, we have all 3 types of opening brackets, and the closing brackets are there immediately after its opening bracket, so it is valid. In third test case, we first have this curly bracket, and it is not closed by this bracket, instead it is closed by square bracket, so it is not a valid string. It should have been closed by this bracket to become a valid parenthesis. So currently it is not valid, so it is so the output is false for this. So as we discussed about stack introduction, whenever we have to evaluate certain order or expression, we can use stack. And for this question, I think we should definitely use stack. If we don't use stack, I think we cannot solve this question. So let's see how we can use stack or data structure. Let's create a stack of type character, because inside string we are going to save each and every character inside the stack. So what we can do is whenever we see one opening bracket, we can push that character inside the stack, and whenever we see a closing bracket, we can pop the elements from the stack. So this is the main idea. Let's see how it works. So whenever we see one opening bracket, let's first check the first test case. We push that inside the stack, and then the next character is closing bracket. So whenever we see a closing bracket, we pop the elements from the stack. So the idea is when we see the closing brackets, we pop the elements from the stack and we expect the element to have the corresponding opening brackets. For example, when we have a closing bracket, we pop the element and the popped element should be the corresponding opening bracket. Similarly for this, it should be this. So the second character, when we see in closing bracket, we pop the element and we see if we have a corresponding opening bracket. If we have corresponding opening bracket, then that is valid. So the first case, we went through all the elements, all the characters inside the string, and we found the proper matching bracket, so we can return true. Again, in the second example, first we enter first we push this curly open brackets. When we see a closing bracket, we pop this element and see if we have a matching closing bracket, and then we push the next element, and when we see the closing bracket, we pop this element and we see if we have a corresponding uh, open bracket for this closing bracket, and then we push the third set of bracket, and when we see a corresponding closing bracket, we pop this element and see if we have a corresponding opening bracket, and after all the characters are covered, when there is no more characters to see, we can return true. Now third example, first we push this opening bracket. When we have this closing bracket, we pop the element and we expect the popped element to be this square opening bracket, but we have this bracket, so we have a non-matching bracket. So when we see this non-matching case, we return false. Yeah, so this is the idea we have to solve this question using stack. Let us try coding this approach. So first let us create a stack of type character. Let us name the stack as stack itself. Now let us iterate the string. We first have to convert the string to character array because we are iterating the type character. Okay, now as we discussed, if the character is an opening bracket, if the character has this opening bracket, or if the character has this opening bracket, or the character has this opening bracket. So if we have, when we have an opening bracket, we push that element inside the stack. In case if there is no opening bracket, it means that there is a closing bracket. Now when we have a closing bracket, then we remove elements from the stack. Now let us store this character in a variable. Okay, now when the character is this, then the removed character must be this. If it is not the case, then we need to return false. So maybe we'll have like this. When we have this closing bracket and the popped element, if it is not this, then let us return false. Yeah. So similarly, the other two brackets. So when we have this character, the popped element should be this. When we have this bracket, the popped element should be this. Okay, now if we always have the matching brackets, then we can return true. Yeah, I think that's it. I think it should work. If it is not working, if we see some problems, we can fix it. Let me run this code. Yeah, so case 1, case 2, case 3 is passing. Let's submit this problem. We have one failure. So what happened is, let's say the input string has only opening bracket and no closing bracket. What happened is we insert one element inside the stack, but we didn't have any elements to any closing bracket to remove this thing in the stack. So maybe what we can do is, instead of returning true, let's check if the stack is empty. In case if the stack is not empty, then it means that there is some opening brackets without closing brackets. So let's try submitting this again now. What happened? Oh, okay. Now what happened is we got an input like this, and in our code, if it is a opening bracket, we push that inside a stack. If it is a closing bracket, then we are popping from the stack. So in this case, we will have an empty stack. There is no opening brackets pushed inside a stack, and when we have an empty stack, we cannot pop the element. So here what we can do is, if the stack is empty, if the stack is empty, then it means there is an either an extra closing bracket, or there is some bracket without any opening brackets. So in this case, we can return false. Yeah, let's try submitting again. Yes, the solution has worked. We can refactor this code little bit. We can have all these three conditions inside same if condition. I think if we do those things, the performance will be little improved, but this is the overall idea by which we use stack and solve this problem. Thank you. Hi, let us see one question where we can use stack data structure and solve the problem. This problem can be solved in many ways, but let us see the way where we use stack and solve this question. So this question, backspace string compare, has been asked in many top companies recently. So let's see what this question is about. So in this question, we will be given two strings. For example, the first string is like this. So in this string, if we see a hash, then it means it is a backspace. So whenever we see a hash, we need to remove the previous character before the hash from the string. So this is a original string. After we remove b, the string will become a and c. We should remove hash as well. So similarly, we have another string a d hash c. So again, when we see in hash, we need to remove the previous character and eventually the hash as well. So after we remove d and hash, it will become ac. So after removing the characters from both the strings, now if we compare these two strings, if they are same, then we need to return true. If they are not same, then we need to return false. So this is the question. In case if we have a string like this, then there is nothing to delete before this hash. So we can simply remove this hash and return it as AB. So yes, this is the question. Let's see how we can solve this. As I said, we can use stack data structure. So what we can do is we can create a stack of type character. Whenever uh, we iterate the string, we can push the characters inside the stack, and whenever we see a character hash, we can pop the element from the stack. So first we insert A, and then we insert B, and then we have hash. So when we see a hash, we remove the topmost element from the stack, and then we add C again. So once the all characters are completed in the string, then we can see what are the elements inside the stack, and we can convert them to a string. So similarly, for the next element, first we can insert A, and then D, and then we have hash. So when we see in hash, we pop the element from the stack, then we enter the next character. So once this string is completed, we again remove the elements from the stack and form a string. So after these two strings are formed, we compare these two and we see if both are same or not. If same, true; if not, false. So this is the logic we're going to build. Let us code this logic. So uh, first we have two strings. We are going to perform the same operation in both the strings. So let us write a method string process backspace, something like this. So this is going to receive one string. So first we will send this string, and then we'll send the other string. So after we receive the string, as we discussed, let us create a stack first, stack of character. So now let us iterate this string. Okay, now if the string is not hash, not equal to hash, then what we do is we push the character inside the stack. If it is not a hash, if it is a hash, then we need to pop the element from the stack. So after we complete this, we can form a string from the stack. So if we use this built-in method of value of, so what it will do is it will convert the elements whatever we have in the stack as a string, and it will return. So now here let us create string1 and call this method and send the first string. So similarly, next we can create string2 and pass d. So once after this uh, element elements are removed, when we see a hash, then we can compare these two string 1 equals string 2. If these two strings are same, then we can return true. If not, we can return false. So this is the idea. Let us try running this. Compilation error. What did it say? Missing semicolon. Public. I think I am having an extra bracket. Okay, let us run again. Okay, so it is working. All three test cases are passed. Let us try submitting now. There is one error. Okay, so what error is saying is we are trying to pop elements from an empty stack. Okay, so in case if the string is like this, so first we have hash. When we have hash, we are trying to do stack pop, but we don't have anything in the stack to pop. So we have to handle this condition. So maybe what we can do is, if stack is not empty, we can pop the elements. If stack is empty, let us not pop. Let us try submitting this again. Yeah. So the solution has worked. So this is how we can use an stack and uh, solve this problem. We can refactor this code a little bit. Like instead of storing it as separate variable, we can directly write like this. Yeah. Uh, Let us discuss the time and space complexity for this problem. The time complexity will be O of n. For this it will take O of n. For this it will again take O of n. So it will be O of n plus n, which is O of 2n. If we drop constant, it will be O of n. And the space complexity for this will be O of n again, because we create one stack, and this stack at the worst case can store all the elements inside the stack. So both time and space complexity is O of n for this problem. Thank you. Hi, let us see this question simplify path. So in this question, they will give us one absolute file path, and we need to convert that path into a canonical path. Let's quickly see what are the rules they are saying. They are saying that the file path should always start with a hash, and two directories must be separated by a slash, and the path should not uh, end with a slash. And also what they are saying is, in the file URL path, we should only have the directory uh, names, like from the root directory to the target directory, and we should not have any single dot and double dot. So those are the rules set by them. Let us quickly check some examples in the whiteboard as well. So uh, the left side part will be the given input from lead code, and we have to convert like the right side. So let's first see what all the rules they said. In the first rules, what they're saying is we should not have slash at the end. That's the first rule. And then what they are saying is we should not have any single dot or double dots. So what happens is the single dot actually points to the current directory. So whenever we see a single dot, we can just replace it with by a single slash. And next what happens is whenever we see a double dot, this double dot actually means that we should go to one directory up. So that is what a double dot means. In case if we have another double dot here, we should have point to this directory. So whenever we have a double dot, we should not point to the directory which is mentioned before. So having this single double dot, we should not point to this third directory. Instead we should have this as the target directory, not this one. So this URL becomes like this. Now the fourth rule is whenever we have a double slash, we can convert it to single slash. So these are the four rules said in question. So how we can achieve this is, let's say if they had only these rules, not having last slash, uh, replacing single dot by slash, and replacing double slash with one slash, we could have easily done this by find and replace using string built-in functions. But the problem here is when we have double dot, we should remove the last directory as target directory, and we should shift the previous one as a target directory. So this is the challenge we have. So this can be solved using stack, because see, whenever we have double dot, we have to remove the last one. So if we use stack, if we enter the directories one by one, and when we see the double dot, we have to remove the last one or the topmost one in the stack. So stack will be very meaningful for this problem. So let's quickly see how we can use stack and solve this. So what we can do is, we can first convert this string to string array. We can split the string using slash, and we can convert it into a string array. For example, let's take this as an example. When we convert this string into string array, we will have something like this: birthday photos, and then third, and then this double dot. So this string will be converted like this. Now what we can do is we can create a string stack, and we can keep adding these directories inside the stack. First we can add photos, and then birthday photos, and then third directory name. And then whenever we see double dot, what we can do is we can remove the topmost element from the stack. So after that, once this string is completed, now we can see whatever is remaining in the string, and we can form the canonical path. So this will be the canonical like this. So this is how we can form. For other cases, whenever we have an empty path or a single dot, we can just ignore it. I mean, we shall not add that into the stack, so that automatically that gets cleared up. So whatever we have in the stack, we are going to use that directories and form the path. So this is the idea we have. Let us quickly code this. So as a first step, we need to convert the string into a string array. Yeah. Then let us uh, iterate the string array. Sorry. Um, okay. Now let us create one stack of type string. Okay. Now let us check the string whatever we have. As we discussed here, if the string is single dot or if the string is empty, let us not add that into the stack. We can continue. In case if the string is double dot, then let us pop the value from the stack. If the string is not double dot or single dot, maybe we can do like this, then we can add that string into the stack. Yeah, so this is the idea whatever we had. After that, we need to iterate what are the elements we have in the stack and form the string. We can take out the stack elements in by two ways. One is by popping the elements, the other way is iterating the elements just like a for each loop. Stack. So when we iterate this element, the values will be from bottom to top. Usually when we pop the stack, the topmost element will come first, but when we iterate like this, the bottommost element will come first. So when we iterate the element, we can create a new string and return that finally string path. Okay, string canonical path maybe. I think we should create a string builder because only when we create a string builder we can append or remove values. Okay, so now sorry append. Okay, so after that we can return this canonical path. Okay, that's all I think. Let's quickly see. Let me quickly see if I've done something wrong. Okay, it looks good. Let us run the code. If any problem, we can solve it. Error. What it is saying? Pop empty stack. Okay, we cannot pop the stack if it is empty. For example, in this case 2, we don't have any elements, so we will not have nothing inside a stack to remove. So what we can do is if stack is not empty, we can remove. Yeah. Okay, now it is working, but this case are failing. Let's see what is happening. Okay, in case 2 what has happened? Case 3. Okay, the directories must be separated by slash. So we have not done it, it seems. So whenever we create one directory, we should add one slash. Okay, let us see run it. Okay, case 1, case 2, case 3, case 4 are working. Case 2 is not working. Okay, so for this one we don't have any path, we have written empty string. Okay, in case if we have nothing, if no path is there, we should return slash and not empty string. Okay, maybe what we can do is we can see if the length of canonical path, if the length is greater than 0, we can return whatever we have. If not, we can return an empty slash. Okay, now let's run it again. Yeah, all are working. Let's submit this code. Yes, it is working. So yeah, that's all about the problem. Let's quickly see the time and space complexity. The time complexity for this problem will be O of n, O of n here, and another O of n. So it will be O of n plus n, O of 2n. If you drop constant, the time complexity will be O of n finally. And space complexity, we create one stack. At the worst case, you can store all elements from the string to stack. So whatever is the length of path, or how many words, whatever the number of words or directories we have in the path, it will be the same time complexity, same space complexity. Yeah, that's it about this. Thank you. Hi, let us see this question next, greater element. This question is from Geeks for Geeks. I did not find the same question in lead code. I will paste this question link in the description. Okay, so let's see this question. In this question, we will be given one integer array of size n. So what we need to do is we need to find the next greater element for each element in the array and replace the next greater element. In case if we don't find any next greater element, then we need to write -1 for that position. Let us see some example. So in this first example, we have an integer array of length 4. So for the first index 0 or first element 1, we need to see which is the next greater element uh, in the right side of 1. So in the right side of 1, 3 is the next greater element for 1. So we replace 1 by 3. Then we take 3 and see which is the next greater element of 3 in this array. When we check, 4 is the next greater element for 3, so we write 4 here. Now we take 2 and we check which element is greater than 2 in the rest of the array. 4 is there and 4 is the greater than 2, so we write 4 replacing 2. And last element is 4, there is no other element left in the array, so which means that there is no greater element as well, so we write -1. So this is the output. Let us see the second test case as well. So in this test case, first we take 6 and see what element is greater than 6 in rest of the array. 8 is the immediate greater element, so we write 8 in place of 6. Now we take 8 and see which element is greater than 8 in this array. There is no element greater than 8, so we write -1 in place of 8. Now we take 0 and see which element is greater than 0. 1 is greater than 0, so we write 1. Now we take 1 and see which element is greater than 1 in the array. 3 is greater, so we write 3. And for the last element, as usual, we don't have any elements to compare, or we don't have any greater elements, so we write -1. So this is the output of example 2. So this is the question. Let us think how we can solve this. We can first think of some brute force approach. So what we can do is we can first take one element and compare all other elements, and when we find a greater element, we can replace that element with this element we compare. And second, we can take other element, again we can compare all other element and replace the next greater element. So this approach is like a bubble sort, or this approach will take two for loops, first element to compare with, and second element to loop through the rest of the array. So this will take O of n square time complexity, and this approach will definitely work. So this is one way of doing it. In case if interviewer asks us to solve in O of n time complexity or in a single pass, we need to think how we can do that. We need to definitely use some data structure to achieve that. So here in this case, we can use stack to solve this problem. By seeing this question, we will actually not remember about stack, or we will not relate this problem with stack, but stack will work for this problem. Generally, stack will work for things like evaluating some order of expression. Also, stack will work in cases like, let's say we want to move forward, and then we want to backtrack to some point, and then again we want to move forward, and again we want to backtrack to some point. So if you want to do something like moving forward and coming backward kind of scenario, stack can be used. So in this case, we are going to do something like this, and stack can be used here. So let's see how we can use stack and solve this problem. Let me take example 1 first. Let me plot these values as a graph. Let's take the array index as x-axis, and let y be the height, 1 2 3 4. So 0 is here, so 0th index 1, first index 3, for second index 2, and third index 4. So graph will be like this. Sorry. Yeah, this is how the graph will be. Now what we can do is we can create one integer stack. Okay. So now what we can do is we can iterate this integer array, and we can use this stack to store index or value, but let us store the index inside the stack because we want to replace the values here if needed. So if we store value, we cannot find the index value of the element, so it is better to store the index value here rather than the value itself. So first we have 1, and there is no element inside the stack, so directly we insert the array index 0 inside the stack, and just for reference I'm writing the value outside to understand better. So 1. So in the first index we have 3. Now before inserting 3, we compare if 3 is greater than array of 0, or in other words, We compare if 3 is greater than uh, the index value whatever is here, that the value in the index value whatever is here. So zeroth value is 1. So we compare if 3 is greater than 1. If the condition is true, we pop this element, and after we pop in the zeroth index, we replace 3. So here in this graph, if you see, if there is no other greater element, or if the element is dipping, then it means for 1, 3 is the next greater element, and we replace this value 1 as 3. And then now there is no element inside a stack, so we insert the index of 3, 1 here. Okay, now after we insert 1, we go to the next index 2. The value in the index, sorry, we go to the next index 3, 0, 1, 2, sorry, 2. The value of index 2 is 2 as well. We compare if 2 is greater than value in first index 3. The condition is false, so we insert second index as well. The value is also 2. Now the last index 3. Now before inserting, we check if 4 is greater than the value in index 2 is 2. We check if 4 is greater than 2. The condition is true. So when this condition is true, we pop this value, the second index. We go to the, this is index, we go to the second index and put the value 4 in 2. Now we again compare 4 is greater than the value in 1. The value is in 1 is 3. We compare if 4 is greater than 3. The condition is again 2. So now we again pop this value, and in the first index we again put 4. Now there is no element inside a stack to compare, so we insert the index 3. The value will be 4. Now there is no more elements to insert or compare. Now at last what we will do is we will empty the stack. We go to index 3 and put -1. So when we don't have any other elements, it means that there is no element greater than the index whatever we have, so we can fill it by -1. So this is how the algorithm will work. So basically, if you see this graph, whenever there is a dip or whenever there is a end, we go back to the previous elements and fill the value of this with the previous elements. So if you draw a diagram like this, whenever there is a peak, we go back to the previous values before the other peak and we update a value here. So yeah, this is how we can solve by using stack. Let us quickly go through the second example as well. So in example 2, again, maybe without graph we can just check with the stack itself. So this is stack. We have 6, 8, 0, 1, 3 array. Let's say this is the array which we have 0, 1, 2, 3, 4. So first we will enter index 0. The value will be 6. Now next we will enter 8. We will compare if 8 is greater than 6. The condition is true. So we will pop this element, and in the 0th index we will put 8. Now we don't have any elements to compare inside a stack. So we enter index 1 8. Now the next element 0, the index is 2. We compare if 0 is greater than 8, the condition is false, so we enter 2 here. Now next the element is 1. We compare if 1 is greater than 0, the topmost element from the stack, the condition is true, so we will pop 2, and in the second index we will replace the element which we compared 1. Now again we will compare 1 is greater than 8, the condition is false, so we will insert index 3 here, which is value 1. Okay, now we will insert, before inserting 3, we will compare if 3 is greater than the value at index 3. So 3 is, we will see if 3 is greater than 1, the condition is true, so we will pop 3, and index 3 we will write 3. Now again we will compare if 3 is greater than the value in index 1 8, the condition is false, so we will insert the index 4 where the value is 3. Now we don't have any more elements to compare from this array. All the elements have been iterated. Now whatever element is remaining in the stack unpopped, 4 and 1 are still there in the stack, so whatever is there we put -1 in the array, because we didn't find any element which was greater than these indexes. So this is how this algorithm works. Let us quickly code this approach. So first let us create a stack of integer. Next let us loop the integer array we have. Now we need to add the elements, we need to add the index inside the array, and before we add, we compare if the array of the topmost element is lesser than array of I. If it is lesser, then we will pop the array index, and in that position we will replace the value we have. Now this thing we need to continuously do till the array, the stack has the least value only. So we will put a while loop here, as we have to do continuously, and also the stack should not be empty. Only when the stack is not empty we can do the comparison, so stack should not be empty. Yeah, this is the approach we thought. So after that, in case if we have any elements in the stack, we can pop those elements as a -1. which means that for these indexes we didn't have any greater element. After that we can return the array itself. Yeah, this is what we discussed. Let's try running this code. Cannot find symbol size. Okay, I think we should put length. Okay. Yes, looks like it has worked as expected. Let's try submitting this. Okay, I think all the test case will pass hopefully. Yeah, test passed. So let's see the time complexity and space complexity. First, the time complexity. Time complexity will be of n as we use one for loop. Um, we don't need to count this while loop because uh, it will not cross more than O of n. So when comparing O of n, this should be lesser. So whichever is more, we take that. So the time complexity is O of n, and the space complexity is again O of n because in the we use a stack, and the worst case we might store all values inside a stack. So time and space complexity will be O of n for this. Thank you.